Welcome to the DIY Honda Garage channel. In this presentation, we will delve into the specifics of the Diagnostic Trouble Code, DTC P0A94, which pertains to a problem with the DC-DC converter's performance in the Honda CR-V 2023 and newer models. The DC-DC converter plays a vital role in electric and hybrid vehicles, converting high-voltage direct current from the battery to lower voltage direct current required for various components. When the powertrain control module, PCM, detects an issue related to this component's functionality, it registers DTC P0A94, indicating an abnormality that requires further investigation. Understanding this DTC and conducting thorough troubleshooting can help restore optimal vehicle performance. This guide will follow a structured approach for diagnosing and resolving issues related to the DC-DC converter, incorporating both inspection items and testing procedures outlined in the diagnostic text. DTC P0A94 refers specifically to a performance problem within the DC-DC converter, a crucial component of the vehicle's hybrid system. The DC-DC converter is responsible for converting high-voltage battery power into lower voltage that can be used by various electrical components and the vehicle's conventional systems. In the Honda CR-V 2023 and newer models, this component is typically located near the battery and the powertrain control module, PCM. Its location ensures that it can effectively manage power distribution, minimizing energy loss during conversion. When the PCM detects a failure or irregularity, it triggers the P0A94 code, indicating a potential issue with the converter's output or input capabilities, necessitating immediate inspection and troubleshooting of the associated circuits. Several possible causes can trigger DTC P0A94. Firstly, a faulty DC-DC converter is the most direct suspect, indicating that this critical component may not be performing as designed, leading to poor power conversion and system failures. Additionally, the powertrain control module, PCM, which orchestrates various vehicle functions and monitors component performance, might itself be malfunctioning, affecting its ability to properly assess and manage the DC-DC converter's operation. Lastly, wiring issues, such as short circuits or open connections in the associated circuits, can disrupt the flow of electricity to and from the converter, leading to the triggering of DTC P0A94. A comprehensive inspection of all potential causes is essential to diagnose and resolve the issue effectively. When DTC P0A94 is active, a range of symptoms can present themselves in the Honda CR-V. A primary symptom is the illumination of the warning indicator on the dashboard, alerting the driver to a potential issue with the vehicle's electrical performance. Additionally, the vehicle may experience power loss, particularly in hybrid operation modes, where the electrical systems may not receive adequate voltage supply. This can lead to noticeable performance issues, including reduced acceleration or erratic behavior when the vehicle is in motion. In severe instances, if the DC-DC converter fails completely, it can result in a total shutdown of electrical functions essential for driving, making prompt diagnosis and repair critical to avoid further complications. The first step in troubleshooting DTC P0A94 involves test driving the vehicle and then stopping the engine using the auto idle stop feature. This procedure allows technicians to gather live data on the system's functioning under real-world driving conditions. During the test drive, it's crucial to observe any unusual behavior or symptoms that may correlate with the issues indicated by DTC P0A94. After completing the drive, using the auto idle stop function can sometimes reset or alter the conditions, causing the PCM to register an abnormality in the DC-DC converter system. This initial step is fundamental in establishing a baseline and understanding the context in which the issue arises, leading to more targeted inspections in subsequent steps. The second step involves confirming the Honda Diagnostic System, HDS, regarding the DC-DC converter cost error. It's crucial to check whether the HDS reports a malfunction status for the DC-DC converter. This diagnostic check provides insights regarding the current health of the converter, helping to distinguish between issues with the converter's output or system miscommunications. If the HDS indicates normal, further investigations may be warranted to explore other electrical components or connections. Alternatively, if a malfunction is confirmed, this directs the troubleshooting focus towards the DC-DC converter and its related circuits, streamlining the diagnostic procedure and enhancing repair efficiency. The third step revolves around inspecting the external circuit associated with the DC-DC converter. This includes checking the DC-STS shorted wire for any possible damage or faults. Technicians should ensure that the DC-STS signal wire is not shorted to ground, which would impede the proper signaling necessary for the converter's operation. It's important to disconnect the relevant connectors and visually inspect the condition of the wiring. Additionally, testing using a multimeter can provide quantitative data regarding resistance and continuity in the circuits. If any abnormalities are detected, repair or replacement of the wiring may be necessary to restore proper functionality and communication between the DC-DC converter and the PCM, preventing the recurrence of DTC P0A94. In this fourth step, technicians should focus on inspecting the DC-DC converter's output circuit to confirm its operational integrity. This inspection involves verifying that there are no aftermarket parts connected that could disrupt the output performance. Furthermore, ensuring that the battery voltage to the converter is at the expected levels is crucial. The absence of proper voltage can signal problems either within the battery or the converter itself. Turning the vehicle to the on mode helps monitor the output status through the HDS while conducting these checks. If either output error value indicates a malfunction, proper replacement of the DC-DC converter may be required to resolve DTC P0A94 and restore normal functioning of the vehicle. The fifth troubleshooting step involves a thorough inspection of the internal circuit of the DC-DC converter. Since there is no direct method to test the converter itself, technicians will rely on HDS parameter readings to verify its internal functionality. By turning the vehicle to the on mode and checking several parameters related to the DC-DC converter, including the cost error and input-output errors, technicians can determine if the converter is the root cause. Normal conditions should indicate that all HDS parameters are within the prescribed limits. If any reading is abnormal, this suggests a failure within the internal components of the DC-DC converter, necessitating further examination or replacement. The sixth step requires technicians to install a known good DC-DC converter to assess whether the existing converter is defective. This approach allows for efficient diagnosis without complete disassembly of the vehicle system. By replacing the suspect converter with one that is confirmed to be functioning, technicians can closely observe whether the original problem persists. If the failure reoccurs, the issue likely resides in other associated components or circuits. Conversely, if the symptoms or DTC P0A94 disappear, this indicates that the original DC-DC converter was at fault and needs replacement, thereby confirming the effectiveness of this step in the troubleshooting process. The final troubleshooting step examines the powertrain control module, PCM, to determine whether it is the source of the issue. After conducting previous tests, if all other components, including the DC-DC converter, have shown normal conditions, it can be inferred that the PCM may be at fault. This module plays an essential role in managing inputs and outputs for various systems in the vehicle, and its malfunction can lead to erroneous DTC readings. During inspection, technicians should look for signs of damage or faulty connections within the PCM. If any defects or malfunctions are identified, repair or replacement of the PCM may be necessary to ensure the vehicle operates correctly and prevents further recurrence of DTC P0A94. After conducting all necessary repairs and replacements for DTC P0A94, it is essential to perform a final verification process to confirm the effectiveness of the performed actions. Clearing the diagnostic trouble codes from the PCM resets the system and stabilizes performance evaluators for further testing. After DTCs are cleared, a test drive should be undertaken once more to ensure that the repairs have resolved the underlying issues previously encountered. Observing vehicle performance and checking for any recreated symptoms or new DTCs during this drive are vital in validating that the repairs were successful. If no issues resurface, the repair process can be considered fully complete, affirming the reliability of the DC-DC converter's operation. Preventive maintenance is a key aspect of ensuring the long-term usability of the Honda CR-V's hybrid system and avoiding future occurrences of DTC P0A94. Regular routine inspections of the DC-DC converter and its related wiring can help detect potential issues before they develop into significant problems. Technicians should monitor electrical connections for any signs of degradation, corrosion, or wear, performing cleanups or repairs when necessary. Scheduled maintenance at defined intervals can assist in mitigating risks associated with system malfunctions. Additionally, advising owners to remain alert for any warning indicators or performance changes during vehicle operation enhances the overall reliability of the vehicle's electrical system. In conclusion, diagnosing and repairing DTC P0A94 necessitates a comprehensive approach involving multiple investigative steps, ensuring the DC-DC converter and connected components are functioning optimally. By reviewing the symptomatology and conducting thorough inspections as outlined, technicians can identify and resolve issues effectively. It's crucial to address any abnormalities promptly to prevent further complications and maintain vehicle performance. Continuous monitoring and preventive maintenance should be part of vehicle ownership to safeguard against potential failures. Ultimately, understanding DTC P0A94 not only aids in immediate repair needs, but also promotes long-term reliability of the Honda CR-V's electrical systems. Please like and subscribe to the channel. See you next time.